Hello, this is our project for position control. This is replicating the Last Minute Engineer's L293D plus stepper tutorial. I'm going to show the wiring and then explain how the L293D's internal H-bridge maps to that circuit. So, for parts and layout, we show the Arduino, the L2993, the NEMA-17 power supply, the breadboard. This approach is based off the Last Minute Engineers tutorial, which drives the stepper via the L293D in a simple full or half step mode. I'm enhancing it with absolute positioning so you could command angles via serial. So we wire it up accordingly based on this diagram. We have our 5 volts, we have our ground. For pins 4, 5, 12, and 13, they go to ground on the L293D. And then we have pin 8 is our 12-volt motor supply. So now you're probably wondering, why did we learn about an H-bridge? Well, the L293D packages 2 H-bridges inside of the chip. So each H-bridge is 2 half-bridges. Each coil of the bipolar stepper is driven by 1 H-bridge. By reversing the H-bridge polarity, you reverse current through a coil. The logic inputs control which transistors inside the H-bridge turn on, which enables the pin gates of the whole bridge. The L293D is essentially 2 H-bridges packed into one single chip. Each H-bridge is used to drive one of the 2 coils of a bipolar stepper motor like the NEMA-17. An H-bridge is a 4-switch circuit that also allows current through a coil to be reversed. So by turning on one diagonal pair of switches, the current flows one way, and by turning on the opposite diagonal, it flows the other way. This reversal of current changes the polarity of the magnetic field in a motor coil, which is fundamental action that makes the stepper advance to the next position. In other words, when we connect the NEMA-17 through the L293D, we're simply using the IC's built-in H-bridges to handle the heavy lifting of switching coil currents back and forth in a controlled sequence.